Yeah, so we have here on the wiki one section about multi-threading. So
yeah, 100,000 foot with this stuff, you end up needing to get fairly far into a problem before you'll even know what you want to do with it. And here's some reference material to get you started when you have a particular workload. I mean, the right thing to do is, try it and be in touch. So.
Yep.
I'm kind of missing, I guess, some of this, and maybe I haven't found it yet. Is one of the things I'm kind of missing, I guess, is a more visual. I'm a visual person, so I like to see what it looks like from a high level, and then we start to drill down into those pictures, and then we start to talk about it. Going directly into the code doesn't really help me understand the bigger picture, I guess, from the outside around sometimes. So it's just the way I look at things.
Yeah.
I don't know if anybody else sees that or not.
That's perfectly valid. It's the kind of thing we'll note down, and we'll see if we can start doing something about it, because what you're getting, unfortunately, is again, as I said, I'm patient zero in the Ebola outbreak. I've been there forever, and I almost don't know what to do to help people get into it. But that's a real good suggestion.
Hey, Damian, one other question, right? If you run this in the I/O worker mode versus RSS, what's the performance delta you see?
Dave, you did that, right?
Yeah, I've done a bunch of that. It typically is not nearly as effective, although it's way better than nothing if you can't get RSS queuing. Or RSS queuing, is one example. The other is just strict interface placement, where you're saying this pipe goes
right.
to that model, which I think the DPDK guys often use. Is perfectly reasonable too.
So do you get, for example, with Mashix 137 million, right? Would you get to, within 20% of that with the I/O worker model? I mean, you are executing more instructions.
Within 20% of it, yeah, probably. We'd have to go work it out.
Okay.
Can be tested. So what's the issue with RSS?
No, not the issue with RSS. It's just I'm looking at a comparative thing between the two models.
So I have a view on this because we did some testing a very long time ago, and hashing is easy.
Yes.
And it's simple, and it can be done in hardware, so we should use it.
Yeah, I mean, hashing is easy in software. It takes about 4 cycles to do in software too when you do vectors. Yeah. So that's not the problem. The problem in software is actually distributing because of the caches.
Yeah.
And there should be some drop in performance there.
Yeah, well, there sure is.
Right. So if I get some guideline from the community, or if in the what do we call it, the CPL, get some guideline, I would love to look at hashing in hardware versus hashing in software for the 4 cycles.
That's kind of what Margaret might be interested in, right?
That's Margaret, is the background for your question to make it independent of hardware?
It's more like what's the environment, and that's part of it that makes you go to one version of a thread versus others. So there's
simply enough, right? If the hardware doesn't understand the overlay that you're running, you can't run RSS.
Yeah, for example, hardware in some cases, hardware maybe is not supporting RSS for MPLS packets.
Okay, so
and if you want to distribute MPLS packets between the worker threads, you will need to go to the software implementation.
All right, guys, I'm convinced, because to me, it's actually the same problem that me, Brian, and Gerald were discussing of having SRIOV versus a virtual switch. So it's exactly the same thing. If we can address it efficiently in software and make it hardware independent for the variety of hardware that's there, because software is portable, then fully agree and game.
So interestingly enough, right, it's just a question of how much of a effectiveness problem we have. You actually bring it all into a bunch of I/O cores and move it to the worker cores and move it back. And obviously, you are executing more instructions. It should be slower. It's just a question of how much slower will it be.
Yep.
Right. Okay.
Yeah. Well, the other thing is, as soon as you hand off packets, you can close your eyes and imagine what that does to the caches, because anything, anything you've dragged in is going to have to get yanked across the cache coherency protocol, in the worst case, possibly to another socket if you get it configured wrong. One of the things that we say to the orchestration guys is, dudes, you absolutely have to have a good map in your head of where you're throwing stuff on a multi-socket platform. Otherwise, what you're going to get is what you'd expect, which is I reach my arm through the QPI bus and I pay for it.
So if I could translate this for the OpenStack heads in the room, this means it would be really, really good if OpenStack allows us to place workloads with NUMA awareness as a minimum. Thank you.
Yeah.
Not yet.
Let's see. I wouldn't say that's flame off, but end of commercial maybe. But it's absolutely true that if you can, if you configure the box, way wrong, you're going to, as I said yesterday, if you structure the computation for the computer's convenience, you tend to get good results. If you do it for your own convenience, your mileage may and probably will vary.
Yep. And what we are trying to do today, we are trying to be NUMA aware at least when we are picking the new buffers and assigning new buffers. But if you have the, card attached to the socket 1, and if you map that card to the worker thread running on the socket 0, it will basically just work slower. So this is something we cannot address automatically. This is something you need to plan to provision properly, right?
So Damian, there's a few other variations that you could do on the same IO worker thread model, right? You could actually use the hardware hashes, and in certain NICs, you can actually pull parts of the packet so that you don't touch the packet and you don't actually cause a cache bounce. In other words, you pull the packet header values into the descriptor and use that to go do your direction, and the packet still remains in LLC that you can pull directly from a subsequent core. So there are variations we can work.
Assuming you're not running a tunnel and cap that's too deep.
Yeah.
Yes. Right.
Too deep.
So there are variations we can work. We should try those out, and I think we will try a few of those out as well.
Yeah. Now, again, a perfect example of something that's clearly coming down the road. The thing you don't want to make it is such an erector set that no human being except Yumi and Damian can set it up so that it works properly. That's, as you see, this stuff, it's a little bit like ogres. Ogres all have layers. They're like onions, and the more you peel the onion, it's great, but you can end up making it so bloody complicated that no human being can deal with it.
No, the biggest thing about onions is it makes you cry.
Yeah, yeah. What I said about my first attempt to do decent multi-core pipelining was that it worked okay, except that I would have had to dress myself up in a gorilla costume and ship myself FedEx every place it was deployed because nobody on Earth could configure it.